Hi. In the last video, we introduced the idea of a derivative of a function. Now what I'm going to do is give you some simple examples which will help you understand how to calculate derivative of any given function. Okay. So we will do a set of examples and eventually we will also talk about the algebra of differentiation. So let's see now. Okay, so let's take some examples. Okay, I have already told you that by f prime of x, which we have defined as this limit, okay. So here f prime of x denotes the derivative of the function f of x. Okay, so let's take a very simple example. Let's say our function is some constant c times x. Okay, c is some number. C could be 3, could be 5, could be 7.5, whatever, or irrational number, doesn't matter. And I want to calculate what's the derivative of this function. Let's put this thing here. Let's see. So first I should calculate x plus h. Okay. This will become what? C x plus h. Now I take the difference, x plus h minus f of x. What is that? That's cx plus ch. This is what you get from here, minus c of x. Okay, substitute it there. So your f prime of x equals limit h going to 0 fx plus h minus fx. I put here, it is c times h over h. Okay, these two cancel, so that now I can take a limit. So before I cancel, it was a 0 by 0 form. Now after cancellation, I can take the limit, which is c. Okay, meaning let me start making a short table here. I will take different functions and their derivatives and I will list them down here. So if I take any constant c of, okay, before I write down here, let me quickly give another example. Even I should have mentioned that before. If your function is just a constant c, then f prime of x would be 0. Okay, can you see that? Because when you take f of x plus h, it will still remain c. Okay, it's a constant. So constant minus the same constant, it is 0. So you are going to get a 0. So I put it here. For a constant, the derivative is 0. If you take x, c times x, it is c. Now you may ask what will be x square, for example, or c times x square. Okay, let's calculate this one now. I'll calculate on another sheet and I'll put everything there. So c x square. Let's see our function. What will be your x plus h? It will be c times x plus h whole square. C times x. So in the numerator, so here it will be is, okay, sorry for a mistake. And this is also a mistake here. So the numerator would become c times x plus h whole square minus c times x square. C let me take out. Okay, c is just going to hang around. So it's okay. So your this thing will be a square plus b square plus 2 ab and then you have minus x square. These two cancel. 2hx plus h square. Okay. Now in the denominator you have h. So your limit h going to 0 is c comes out, h goes to 0, 2hx plus h square over h. Okay, I can cancel h. Okay, and this is going to give 2x, and this term is going to go to 0. So your answer is c times 2x. If you put c equal to 1, you get 2x. So let's put it in our table. So forget c, let's put c equal to 1, it's not necessary here. How about x to the n, where n is an integer? Okay, I'll take n to be an integer. Or let's say for the time being positive integer. What will be the derivative of x to the n? To get the derivative of x to the n, let's go back and look at what we did for x square or cx square. So in this step, all that is important is what you get here. The term which is linear in h. Any term which was of higher order, meaning h square or h, even if there was an h cube term, they all will give 0 contribution. So what you really need to know is the term which has one factor of h. Okay, and that is what we really need. So let's see how we get the derivative of x to the n. Okay, just imagine x is, for example, 10. Okay, so in the numerator again I have x plus h to the n minus x to the n. Okay. This piece, what is that? It is you can use, of course, the binomial theorem, but I will want to emphasize something. So these are n such factors, okay, n factors. So if let me see what I get when I multiply all this. So if I take x from each of these and multiply them together, I generate the term x to the n plus. If I take one h and all others to be x, I get h x, right? But this will appear many times. If I take h from here and x from all others, I get hx to the n minus 1. If I take h from here, x from all others, I get again hx to the n minus 1. And in how many ways I can do that? I can do that in n number of ways. I can pick h from this one, or from that one, or from that one. Okay, and they will all add up and give you n hx to the n minus 1. Now to me it is of no concern what the coefficients are of other terms. Why? Because let's say whatever that coefficient is, I put it hash, denoted by this number, and you will have h square x to the n minus 2 plus some number which you can easily determine, but you don't have to, and you at the end get h to the n. Okay, that one will be 1 anyway. Now let's let's take the derivative. How do I do that? I take the numerator. Numerator will be x to the n plus n h x to the n minus 1 plus something h square x to the n minus 2 plus so on and so forth plus h to the n minus x to the n coming from here. Okay, which will cancel, and I take now the denominator, which is h, and divide. When I divide by h in the formula for the derivative, which is here, this denominator h, it will cancel that h and leave behind n x to the n minus 1 plus this will leave a term linear in h, so it will have some number here which is there, that one, x to the n minus 2 plus other terms which are all with increasing powers of h. Okay, that's what you're going to get. Now let's take the limit. What you're going to get? Only this survives. All others will give you 0 because h goes to 0. you get n x to the n minus 1. Okay, so for x to the n, you get n x to the n minus 1. So if you have, for example, function to be x to the 12, then your f prime x is 12x to the 11. We'll see more examples in the next video.